In this video, we're going to be talking about standard in, standard out, and passing data from Tcpdump to other programs. So first off, you typically read a pcap file like this, right? And we're just going to print one packet. You read it in and it prints it out. Well, if we actually pass it, or we tell Tcpdump to read from standard in, that it reads from a file descriptor that's set up. And we can do this by catting a file to standard in, which is the requirement. You have to pass something that someone standard out, and that by someone I mean the program. In this case, the program standard out, which is cat standard out, to Tcpdump standard in, and then it'll read the file just fine. So this kind of shows you how you can take the output or input of Tcpdump and do other things with it by chaining commands together. So let's try tcpdump -ni eth 1, and we're going to print one packet, and we're going to write it to standard out. Instead of specifying the file name, we specify the dash. Whoops. Oops, gotta need permission to do that. Of course, sudo, always forget. And you can see right here that there's a bunch of data, a bunch of binary data, gobbledygook, and that is what actually happens when you specify the dash. Because remember, the dash W tries to write it to a file, so it uses the pcap binary format. If you specify the dash, it tries to write that to the screen. So if we go back and we print 2 packets, you'll see more crap. Yep. A bunch right there. So what we need to do is we want to pass this to something that can do something with it. You can redirect this directly to a file. So test, or we already have that. So binary.file, and we'll go ahead and see if that does something. Give it a second while it tries to get a few pcaps and or packets, and it has some. So let's do file binary.file. You can see that it is a pcap file, and we can try to read it in with another version of or with another instance of Tcpdump, and blah blah. There it is, 2 packets that were captured there. Great. So we actually wrote out the binary directly to standard out, and then used the shell to redirect that binary to a file. Just kind of showing you the workflow of this. Now, you may have a time or a case where you actually want to capture packets live, such as from an interface, and then pass it to another instance of Tcpdump to do the parsing. So the idea here is, instead of having one instance do all the work, then the second instance is what actually filters or does something for you. One just writes, the other does some parsing or analysis. It doesn't have to be just with Tcpdump. You can have another program that Tcpdump is writing to, whether it's tshark or ngrep or snort or bro, etc. It's possible to do those things. But let's focus on Tcpdump, since this is the Tcpdump module. Now, what we're going to do here is we're going to write to standard out binary packets, for our packets in the binary format, and then we're going to read it in to Tcpdump with the -i, just to demonstrate these pipelines. And you'll see this isn't all that useful, but it allows you, it just kind of demonstrates the power of this. They're waiting. So either packets haven't arrived yet, or they're being buffered, which gets to another point of an option that you should be familiar with. There's actually being buffered, so go ahead and kill this. It might take a little bit of time. So if we cancel that, yeah, so it only captured 12 packets, and that wasn't enough for it to actually pass those to the next program. So you have to specify the -l option to say the line buffer the packets. And in this case, it's actually, as they're coming in, passing them over to the Tcpdump, other Tcpdump instance reading from standard in. Let's go ahead and try something. Let's try to sniff on a interface that has more data. Is it eth? Well, that is quite a bit right there. Let's try eth1. Yeah, nothing there. Let's just see how long it takes to do the buffer one. There's a lot more traffic coming in now. So let's Let's do this and I'll time it. Hopefully it won't take too long. Then we can see how many packets were required for it to fill the buffer and then pass it along to the second tcpdump instance. Well, while that's going, we'll go ahead and background it. And then run in the background. Okay, so for the next part of this, we're going to actually just take the data and just pass it. Oh, there it is. So how many? Oh. So around 100 that were fully captured. So we had a buffer around 100 packets. We don't know the exact number because I wasn't able to stop it right on time, but probably about 100 packets that allowed that was required before it actually passed those packets to basically from here to the second tcpdump instance. Okay, I'm gonna go ahead and clear the screen. Now let's talk about tcpdump and just basically using other tools like the Unix command or the basic Unix tool set to read and write from tcpdump's ASCII output. So what we're going to do is we're going to tcpdump, and I'm going to load this specific pcap file I want to try, which has got some TAC traffic in it, I believe, troba.pcap. And we're going to say, go ahead and print one just to make sure it's right. Yep. What we're going to do is we're going to pipe it to grep, and we're going to tell grep to match every line that has a GET request. You can see there's quite a few of them. Those are streaming by the screen. And we can do something else, just basic command line parsing. And this is going to match from GET to the end of the line. It's going to match every character after. And now we just have the GET requests. And we can see specific URLs that people are visiting that were done in this PCAP or when this PCAP was taken. CNN article for 2008 for crime, Oklahoma girls, Katrina supplies, some stuff, more CNN. What else we got in here? Does anything stand out? Some apparel, so there might be some shopping going on. A lot of images, new office, just a bunch of stuff. Some web objects from MZ Store Services. I wonder what that is. That could be interesting. But yeah, you can just kind of see how we're able to quickly get information by parsing it. Let's try another example. We'll use awk, which is a pattern language, for a formatting pattern language. And we're going to say, hey, print the third field of the packets. And the third field happens to be, in most cases, the first IP address. And basically what we're doing, let's just go ahead and show you how that's working. So you say awk's default delimiter for fields is a space, or any sort of white space that's not a new line. And we have this, field 1, space, field 2, space, field 3. Then space, field 4, space, field 5. So if you actually want to get just the source and destination IP address, we can use awk again, and we'll say 3 and then comma 5. And voila, we do. It's have it, but let's make it a little bit prettier. Let's add a new line, or I'm sorry, a tab in there. Now we have it formatted in a little better way. So now we can be like, oh, I want to find all the stuff matching. I can just search. We can do it like this. Port 80. So now these are all the connections to and from that have port 80 involved in it, right? It would also match things where 80 was in one of the octets of the IP address. But just to quickly do things like this is really nice to be able to separate all this data. So this kind of gives you an idea of how you can use this by piping data from tcpdump to other tools to pull out useful information. Next, what we can do is we can show you those tools that are included in the Debian package. So show you real quick here. We have a few example scripts that are awk scripts that we can use just to do more parsing. Let's take a look at one of them or two of them, see if they do anything interesting. So this is going to format it in a certain way. So let's try that one. So that is packet.dat.awk. And how we do this is we'll read in a pcap file again. We'll do this nitroba.pcap. And then what we're going to do is we're going to pass it to awk-f to read that file, which reads the awk script. Okay, so it actually formatted a bunch of information from it, tallying the number of packets sent, the number of ACKs, etc. That's kind of nice. Let's see what else is available. Let's grab awk. We got send ACK. Let's try that one. Sounds cool. What does it say? We need the number of bytes in a packet to do the output. Okay, so it's going to compare byte sizes. It's going to print send time, start sequence. Okay, it's going to nicely print some TCP data. Sequence and acknowledgement numbers. So let's do this one now. Just go ahead and say run sendack.awk. Yeah, nice. So for every single packet, it's printing the sending address and sequence numbers formatted and acknowledgement numbers formatted. That's kind of cool. So you can see how you can also write these scripts yourself to do certain to pull out certain data or fields that allow you to you know, just be able to choose what you want. Okay, one of the things to note about standard out and standard in, etc., is when working with more than one pcat file. So we talked about how cat, you just catting that file from the binary format and saying, hey, tcpdump read the binary input using the standard in option to R works. But if you have two files, so what else do we have here? We have rip or john.pcap, and you can see at the bottom it says Ethernet, and which didn't finish, says ether didn't finish, and it says pcap loop bogus save file header. So what's actually happening is cat is passing this one first. That one actually completes, and then it receives the global header of the next pcap file, which is a 24-byte header that starts off every pcap file. After that is the per packet header that has the timestamp for each packet, and then the packet after, all the way down until the file is finished. So what's happening is tcpdump is expecting another packet header, but is then past the header of john.pcap, the global header, so it fails. It doesn't understand that. It's not designed to read that. So to be able to go through multiple files, you have to merge them together with the tool that's available with Wireshark, for example, called mergecap. There's other tools also available. Or you can use some command line trickery, which we discussed in another video in the libpcap module. And then another way to do it is just kind of loop through the different files. So we can do a for loop. So if you're familiar with the shell, you can do for, and you can say any number after, any value after this. So for I in, I'm just using I, could be num. So just go ahead and use num. Or actually, let's just do for file in pcat, and we'll say, just to show how it works, echo file, blah blah blah. Whoops, not if do done. Okay, so what it's going to do is it's just going to for anything that matches this is stored in a temporary variable called file, and then when the body executes of the loop, it echoes the value of file, and that's substituted for what file contains, and that is these things that it matched up here with the star, and then it's done. So if we want to actually do something with tcpdump, though, we actually have to say tcpdump -nr file, and then I don't know, what do you want to do? Print 3 pcaps, or print 1 packet from each, right? And that's what it did. This is from john.pcap, this one packet, and this other one is from test.pcap, and that is a single packet. So that's how you iterate through multiple files. That's one way to do it. So Now we'll conclude this lesson.